Our tactical team has been monitoring a systematic collapse that most news outlets missed entirely. On January 3rd, in a coordinated operation lasting exactly 160 minutes, every Chinese-manufactured radar system across South America experienced what engineers are calling catastrophic cascade failure. But this wasn't equipment malfunction. This was surgical warfare, and the implications extend far beyond the Western Hemisphere. For the past decade, Beijing invested over $14 billion building what they branded the Digital Silk Road across South America. The centerpiece was the JY-27A wideband surveillance radar, marketed aggressively to nations seeking independence from American intelligence networks. Venezuela bought 6 units. Bolivia purchased 4. Nicaragua installed 3 along their Atlantic coast. These weren't commercial transactions. They were strategic placements in what Chinese military planners called the cerco electronico, the electronic encirclement, designed to create a sensor network capable of tracking every American military movement from Texas to Tierra del Fuego. The sales pitch was intoxicating for leaders like Maduro. Chinese technical teams arrived in Caracas promising their VHF radar could detect F-35 Lightning fighters at ranges exceeding 350 kilometers. They claimed the JY-27A's breakthrough was exploiting a fundamental weakness in stealth technology. American jets achieved radar invisibility by absorbing X-band frequencies, but they couldn't hide from lower VHF wavelengths. The physics were sound. The Venezuelan generals were convinced they'd purchased a system that made American air superiority obsolete in their airspace. Installation began in 2017. The primary array went active outside Caracas at La Carlota Air Base. Secondary units deployed to Maracaibo, Puerto Cabello, and along the Colombian border. Each installation came with a support package. Chinese technicians, Chinese training programs, Chinese maintenance contracts. The radar towers became permanent fixtures staffed by PLA technical officers wearing civilian clothes. Our intelligence analysts noted something else. Every installation included hardened communication bundles running dedicated fiber lines back to a central processing facility that Venezuelan personnel weren't authorized to access. By 2021, the network was operational. Caracas was feeding real-time air traffic data covering 12 nations directly to the 3rd Department of the PLA General Staff in Beijing. The Venezuelans believed they controlled the system. They didn't. They were hosting nodes in a surveillance grid that extended across the entire continent, with every data packet routing through servers in Hainan province before analysis results returned to local commanders. Then came January 3rd, 2026. Our tactical intelligence indicates the operation commenced at 0347 local time. The target was a logistics compound outside Valencia, Venezuela, approximately 160 kilometers from Caracas. The facility had been identified as a transshipment point for Iranian drone components entering South America. The raid itself was unremarkable by modern standards: 4 aircraft, minimal footprint, complete before dawn. But the radar performance during those 160 minutes revealed something that has sent shockwaves through every military planning cell from Taipei to Tehran. The JY-27A installation at La Carlota should have detected the inbound strike package at maximum range. The system was designed specifically for this scenario. Instead, at 0351, exactly 4 minutes after the American aircraft entered Venezuelan airspace, the primary radar array executed what engineers call a spontaneous reboot cycle. Every display went dark. When the system attempted to reinitialize, it encountered corrupted firmware and entered a diagnostic loop. The radar was effectively blind. Venezuelan operators immediately assumed equipment failure and switched to the backup array at Maracaibo. That system lasted 90 seconds before experiencing identical symptoms. Technicians tried manually forcing a cold restart. The radar accepted the command, began its boot sequence, then crashed again at the exact same point in the initialization process. By 0415, 4 of Venezuela's 6 JY-27A installations were cycling through endless reboot attempts. The remaining two had automatically disconnected from the network and refused all remote commands. The American aircraft completed their mission and departed Venezuelan airspace at 0532. The radars remained non-functional for another 96 minutes. When Chinese technical teams finally isolated the problem, they discovered something that caused immediate panic in Beijing. This wasn't a sophisticated cyber attack exploiting software vulnerabilities. The attack had originated from hardware backdoors embedded in the radar's own processing chips. Backdoors that Chinese engineers had installed deliberately during manufacturing. Our technical analysts have been examining the Shadow Link protocol for 18 months. This is deeply classified material, but enough has leaked through defense contractor networks to reconstruct the basic architecture. Every JY-27A radar built after 2016 contains a secondary processing layer manufactured at the Semiconductor Manufacturing International Corporation facility in Shanghai. These aren't standard commercial chips. They're application-specific integrated circuits designed for military signal processing. Built to Chinese military specifications, and they contain what's known in the intelligence community as a hardware implant. The implant is microscopic, embedded directly into the chip die during fabrication. It's not something you can detect through conventional inspection. The functionality is straightforward. When the chip receives a specific authentication sequence broadcast on a predetermined frequency, it activates a secondary instruction set that supersedes normal operations. In layman's terms, the radar stops listening to its Venezuelan operators and starts taking orders from whoever transmitted the authentication code. Beijing installed these implants for precisely the reason you'd expect. They wanted guaranteed access to every radar they sold, regardless of which government operated it. If Venezuela decided to deny Chinese technicians access, or if political leadership changed and the new government wanted to purge PLA influence, Beijing could still extract intelligence or disable the systems remotely. It was insurance against loss of control over their own technology. U.S. Cyber Command identified the Shadow Link protocol in 2023 during forensic analysis of a JY-27A radar that Pakistan had quietly sold to American intelligence. The discovery triggered an immediate black program. If Chinese radars contained hardware backdoors that Beijing controlled, could those same backdoors be exploited by adversaries who knew the authentication protocols? The answer was yes, and the implications were staggering. The operation on January 3rd was the first combat deployment. Cyber Command broadcast the Shadow Link authentication sequence from an EA-18G Growler operating in international airspace north of Venezuela. The signal was encrypted, highly directional, and lasted less than 3 seconds. Every JY-27A radar within range received the authentication, validated it against the embedded protocols in their Chinese chips, and immediately transferred operational control away from Venezuelan operators. What happened next was deliberately designed to maximize confusion and delay recovery. Instead of simply shutting down the radars, Cyber Command instructed them to begin corrupting their own firmware. The systems started overwriting calibration data with random values, deleting portions of their operating systems and modifying boot sequences to fail at critical checkpoints. When Venezuelan technicians attempted emergency restarts, the radars would initialize just far enough to appear functional, then crash. It looked like cascading hardware failure, not enemy action. The beauty of the attack was its deniability. Venezuelan engineers spent hours convinced they were dealing with equipment malfunction. They called Chinese technical support, who initially suspected the same thing. Only when identical failures manifested across multiple geographically separated installations did the pattern become obvious. By then, the American aircraft were 400 kilometers away, and the mission was complete. But the failure didn't stop at Venezuela's borders. Our intelligence network tracks 18 active JY-27A installations across South America. Within 72 hours of the Caracas incident, 14 of those systems had either gone offline for emergency maintenance or begun exhibiting what operators described as erratic behavior. The Bolivian installation outside Santa Cruz started reporting ghost targets, phantom aircraft that appeared on scopes but couldn't be corroborated by any other sensor. Nicaragua's coastal array developed a 20-degree blind spot that technicians couldn't explain or correct. The technical teams understood exactly what was happening. If the shadow link vulnerability had been exploited in Venezuela, every JEI-27A worldwide was potentially compromised. Chinese engineers began emergency inspections, pulling processing modules and examining them under electron microscopes, searching for the implants their own government had hidden in the hardware. They found them, of course, because the implants were there by design, but finding them didn't solve the problem. The backdoors were integrated into the chip architecture at the foundry level. You couldn't remove them without replacing every processor in every radar system. Beijing faced an impossible choice. They could admit publicly that their military radar systems contained hardware vulnerabilities that hostile intelligence services had weaponized, which would destroy the credibility of every Chinese defense export worldwide. Or they could quietly advise their clients to take the radars offline for upgrades, which would leave those nations blind and expose the systems as unreliable precisely when they were needed most. Either option was a strategic catastrophe. The experts we've consulted in signals intelligence describe this as the most significant compromise of foreign military technology since the Soviet radar installations went dark over Libya in 1986. But the historical parallel doesn't capture the full scope of humiliation. The Soviets lost their radars to American jamming technology. The Chinese lost theirs because American intelligence services hijacked the backdoors they'd installed to spy on their own customers. In Caracas, the reaction evolved from confusion to anger to something approaching despair. Venezuelan military leadership had invested enormous political capital in the Chinese radar network. They'd assured their officers that this technology would guarantee airspace sovereignty. Maduro himself had given speeches praising the systems as proof that Venezuela could defend itself without American interference. Now, those same systems had been turned into liabilities, their Chinese engineers admitting they couldn't guarantee the radars would function when needed or that they wouldn't actively assist enemy operations. The operational implications rippled across every military planning cell in South America. If you're a defense minister in Bolivia or Nicaragua and you've spent hundreds of millions on Chinese early warning systems, what do you do when those systems prove vulnerable to the exact adversary they were purchased to detect? You can't simply replace them overnight. Western manufacturers won't sell you equivalent technology, and even if they would, you can't afford it. You're locked into dependence on equipment you now know is fundamentally compromised. But the real audience for this demonstration wasn't in Caracas or La Paz. It was in Taipei and Beijing. Every sensor array that China plans to deploy for an amphibious assault on Taiwan uses the same foundational technology as the JY-27A. The HQ-9 surface-to-air missile systems rely on similar radar architectures built with chips from the same Shanghai fabrication facilities. The coastal defense networks that would provide early warning of American carrier groups approaching the Taiwan Strait all contain processors manufactured under the same military specifications that included the shadow link implants. Chinese military planners have spent 2 decades developing what they call their anti-access area denial strategy in the Western Pacific. The concept is elegant. Deploy enough sensors, missiles, and electronic warfare systems to make it prohibitively costly for American forces to operate within the first island chain. Create a defensive perimeter so dense that even if the United States wanted to intervene in a Taiwan scenario, the losses would be politically unacceptable. The entire strategy depends on sensor networks that can detect, track, and target American ships and aircraft in contested airspace and waters. If those sensors can be remotely disabled or subverted using the same techniques demonstrated in Venezuela, the anti-access strategy collapses. You're not facing a near-peer competitor with sophisticated area denial capabilities. You're facing an adversary whose most critical systems contain exploitable backdoors that you yourself installed. This is the nightmare scenario that keeps Chinese defense planners awake. They can't redesign and replace every chip in every radar system. The manufacturing timelines alone would take years, and even if they could accelerate production, they'd have to admit that current systems are compromised, which would be a propaganda disaster. But continuing to rely on vulnerable technology means accepting that in any future conflict with the United States, your sensors might fail at the exact moment you need them most. Taiwan's defense ministry has been notably quiet about the Venezuela incident, but our sources indicate their American advisors have been far more explicit. The message being communicated through back-channel military liaisons is simple. China's most advanced radar technology can be remotely disabled by systems the United States already has deployed in the Pacific theater. If Beijing attempts an amphibious operation, they'll do so knowing their early warning networks could go dark without warning, leaving their forces blind to incoming counterattacks. The psychological impact of this vulnerability is difficult to overstate. Military operations require confidence in your equipment. Pilots need to trust their aircraft. Tank commanders need to trust their armor. Radar operators need to trust that when they see a target, it's real, and when they see empty airspace, it's actually clear. The Shadow Link compromise destroys that confidence. Every Chinese radar operator now knows their system contains hidden functionality that could be activated by an adversary. Every time the display shows normal operations, there's doubt. Is this accurate, or am I seeing what someone else wants me to see? We've observed Chinese technical teams quietly withdrawing from installations across South America. The official explanation involves scheduled maintenance and routine upgrades. The reality is abandonment. Beijing is pulling its personnel because the political cost of having them present when the next failure occurs is too high. Better to leave the systems with local operators and claim any future problems result from improper maintenance or operator error. The Venezuelans are learning what it means to be a client state in China's sphere of influence. They purchased technology they were told would guarantee their security. What they actually received was equipment that made them more dependent on Chinese technical support, more vulnerable to Chinese intelligence collection, and ultimately more exposed when that same technology was turned against them. The radars still stand outside Caracas, massive installations that represent hundreds of millions in investment, but nobody trusts them anymore. There's a broader lesson here about the economics of military technology. Advanced weapon systems look identical on sales brochures. Every country claims their radars can detect stealth aircraft, their missiles can defeat any defense, their electronic warfare systems can dominate the spectrum. But the critical difference isn't in advertised performance. It's in who controls the underlying technology, who designed the chips, who wrote the firmware, and who can access the systems when they're deployed in the field. Western defense contractors learned this lesson decades ago after the Jonathan Pollard espionage case and subsequent compromises. Modern American military systems use supply chain security protocols specifically designed to prevent unauthorized hardware implants. Processing chips for critical applications are manufactured in trusted foundries under constant surveillance. Firmware undergoes cryptographic verification. Communications protocols include authentication layers that prevent unauthorized access even if someone knows the technical specifications. The Chinese defense industry developed rapidly over the past 20 years, but it did so by prioritizing speed over security. They needed to field competitive systems quickly to support aggressive export campaigns. That meant cutting corners, using commercial foundries with minimal oversight, and building in backdoors to maintain control over exported technology. It worked brilliantly for building market share. It's failing catastrophically now that adversaries understand the vulnerabilities. The engineers who designed the Shadow Link implants never imagined American intelligence services would identify and exploit them. They assumed the authentication protocols were sufficiently obscure and the systems sufficiently isolated that reverse engineering would be impossible. They were wrong. And now every radar system China has exported since 2016 is suspect. Every foreign military that purchased Chinese surveillance technology is questioning whether they bought a security asset or a liability. In Beijing, the Central Military Commission is conducting damage assessment on a scale not seen since the EP-3 incident in 2001. They're trying to catalog every system that might contain compromised chips every installation that might be vulnerable to shadowlink exploitation, and every foreign deployment that might fail during actual combat. The numbers are staggering. We're talking about hundreds of radar installations, thousands of missiles, entire air defense networks across dozens of countries. The financial implications alone are devastating. Countries that purchased Chinese military technology expecting decades of service are now facing the prospect of premature replacement. But replacing Chinese systems means approaching Western or Russian suppliers, which creates new dependencies and political complications. Some nations will simply accept the vulnerability because they have no alternative. Others will reduce their reliance on radar entirely, which degrades their defensive capabilities, but at least eliminates the specific shadowlink threat. Russia has been watching this unfold with particular interest. They've purchased Chinese military electronics for integration into their own systems. If those components contain hardware implants that American intelligence can exploit, Russian air defenses face the same vulnerability. We've seen indications that Moscow is conducting its own forensic analysis of Chinese-supplied chips, looking for implants they weren't told about. The diplomatic tension this creates between Beijing and Moscow is subtle but real. For American defense planners, the Venezuela operation validated years of investment in offensive cyber capabilities. The ability to remotely disable adversary sensors without firing a shot represents a revolutionary capability. It doesn't eliminate the need for traditional kinetic weapons, but it changes the calculus. If you can blind enemy radar before your aircraft enter contested airspace, you dramatically reduce losses and increase mission success rates. The tactical applications extend beyond radar systems. Any modern weapon that contains microprocessors manufactured in potentially hostile facilities could theoretically contain hardware implants. Missiles, drones, communications equipment, even vehicles and ships with sophisticated electronics all represent potential vectors for this kind of attack. The Venezuela demonstration proved the concept works. Now, every military with access to similar capabilities is examining their adversaries' supply chains, looking for exploitable vulnerabilities. This is the new reality of modern warfare. The battlefield isn't just physical terrain, it's the electromagnetic spectrum, the cyber domain, and increasingly the supply chains that produce the weapons themselves. Dominating those domains requires capabilities that most nations simply don't possess. You need advanced signals intelligence to identify vulnerabilities, sophisticated cyber warfare teams to develop exploits, and the manufacturing infrastructure to ensure your own systems aren't similarly compromised. The Chinese officials who designed the digital Silk Road envisioned creating technological dependencies that would give Beijing influence over nations across the developing world. They succeeded in creating the dependencies, but they failed to anticipate that the same technologies they'd weaponized for intelligence collection could be turned against them by adversaries with superior technical capabilities. In Caracas today, the JY-27A radar towers still stand, but they're mostly idle. Venezuelan operators run daily diagnostics, but nobody believes the results. Chinese technical teams promise software patches that would address the vulnerabilities, but those patches never materialized because you can't patch hardware backdoors. The installations have become monuments to a failed strategy, billion-dollar investments that provide more psychological liability than military capability. The message to other nations considering Chinese military technology is unmistakable. You're not buying sovereign capability. You're buying dependence on systems that the manufacturer can access, that adversaries can compromise, and that will fail when you need them most. The radars looked impressive in demonstrations. They failed completely in combat. That gap between marketing and reality is the difference between nations that manufacture cutting-edge military technology and nations that assemble it from components they don't fully control or understand. Chinese engineers are undoubtedly working on next-generation radar systems that address the shadowlink vulnerability. But developing new chips, validating their security, and deploying them at scale takes years. In the interim, every existing installation remains compromised. Every foreign military operating Chinese sensors knows they're vulnerable, and every potential customer watching from the sidelines has seen what happens when you trust your national security to technology controlled by someone else. The lasting image from this incident isn't the American aircraft completing their mission undetected. It's the Chinese technical teams quietly packing their equipment and leaving Caracas, unable to explain to their Venezuelan counterparts why the radars they'd promised would stop invisible American jets couldn't even detect conventional aircraft operating in plain sight. That's the humiliation that will resonate across every defense ministry that considered Chinese technology as an alternative.